this is the summary of chapter number 1, 10 Science, Chemical Reaction and Equations. Right? We have already learned about different topics ranging from how to write the chemical reactions, how to balance. Now we'll just try to summarize that items. For example, pan, when kept open in the air in the presence of oxygen, gets oxidized, right? Respiration and digestion, they are the biggest example of the chemical reactions. So these are the rusting, corrosion, rancidity, these are the different types of the chemical examples, chemical reactions examples. When we eat, food get digested, right? It is also chemical reaction. When we inhale the oxygen and when we exhale, we inhale oxygen and comes out is the carbon dioxide. So this is the reaction which takes oxygen, combines with the carbon and put out the carbon dioxide. This is also a chemical reaction. So all these are the chemical reaction. Now when magnesium burns in the presence of oxygen, a white powder of dazzling light is produced. White powder of magnesium dioxide is formed along with the dazzling light. This is also a chemical reaction, magnesium plus oxygen. So now it's time we can define the chemical reaction. So what is the chemical reaction? A process in which one or more substances, when combined with different one or more substances and produce totally new one, two or more than two substances, they are known as chemical reactions. A process in which one or more substances converted to one or more different substances having different chemical properties. Actually, reactants are converted to products. The items which take part in the reaction, and the items which are produced, they are known as products. The items which take part in the reactions, they are known as reactants. So reactants react with each other to produce the products. It may be generated or may be required to be given. Size, shape, smell and physical properties may be changed. Now let us compare the physical and chemical change. Actually, no new substances are formed in case of the physical reaction, but in case of the chemical reactions, new substances are formed. Properties of the substance remains almost same in case of the physical change, but properties of the substance drastically change, altogether change in case of the chemical reactions. Chemical reactions are mostly irreversible, whereas physical change are mostly reversible. Mostly change of state will be there in case of the physical change, and chemical properties, they are having totally different types of change. For example, when ice is heated, it becomes liquid, water. When water is heated, it becomes steams. Means when you again cool the water, it becomes ice. So solid ice, liquid gas, they are interchangeable with the help of the temperature change. Ice cream, when it becomes heated, it becomes liquid in the nature, but when it is again cooled, it again takes the form of ice cream, solid ice cream. But is it possible to retrieve the burnt wood to a wood shape? Is it possible to bring back the wood after burning? No, it is not possible to get back wood from the ash because it is a chemical reaction, right? So how to write the chemical reaction? For example, we had discussed about the burning of magnesium in presence of oxygen giving white dazzling light, right? And white powder. So we may write in a word, magnesium when reacts with the oxygen gives magnesium oxide. So this is a verbal expression written form. Now reactant 1, that is magnesium, combined with the reactant 2, that is oxygen, and produces magnesium oxide, that is product number 1. Symbolically, because it is very much cumbersome, very much complex to write the full equation in words, so we write by symbol that Mg, that is magnesium, when reacts with O2, means oxygen, produces MgO. So this is known as chemical reaction in form of notations. Now how to balance these equations? In accordance with the law of conservation of mass, we know that some of the reactants should exactly match to some of the products. So when we match exactly number of atoms, for example, in case of this reaction, if we place 2 magnesium and reacts with the oxygen 1 molecule, that is O2, it gives 2 molecules of oxygen, MgO, means total number of magnesium is 2 in case of the reactants as well as the products. Number of atoms on product side, that is oxygen, is also 2, on reactant side is also 2. Hence we say that the equation is balanced. Is it balanced? Yes, it's balanced. Now, how to mention the physical states? Means solid, liquid, gas. Take example of this equation. 3 molecules of ferrous when combines with the 4 molecules of water, that is H2O, it gives ferrous oxide, that is Fe3, ferrous oxide O4, and 4 molecules of the hydrogen gas. Now this is a balanced equation, no doubt at all, but actually we have not mentioned what states are there. So if we mention the states, physical states, for example, 3 molecules of Fe, they are solid in the shape and solid in the nature, and 4 molecules of water, they are gas in the nature. When they combine with each other, they produce Fe3SO4, that is solid in the nature, and 4 molecules of hydrogen, that is gas in the nature. So this is the perfect way to write the equation chemically. But one more thing yet missing there, and that we will have to mention the agents, or for example light, chemical, heat, enzymes, etc., which are necessary to carry out the this reaction. So law of conservation of mass says mass can neither be created nor be destroyed. Means number of atoms on both sides must remain equal. Physical state should also be mentioned in chemical equations. Pressure, temperature, etc. For example, chlorophyll, sunlight, etc. should also be indicated above the arrow. Now, what about more about chemical reaction? During chemical reaction, atoms of one element do not lose, do not convert into another element. They simply form combination of with different elements. Simply formation of atoms will be changed. Number of atoms of any element will be as it is as in the reactants as in the product. Means, for example, 4 atoms of the hydrogen is there in case of the reactants. In case of the products also, only 4, ना कम ना ज़्यादा, ना 3 ना 5, 4 मतलब 4. अगर reactants में 4 है तो product में भी 4 ही रहेंगे. So a process of breaking and making of chemical bonds takes place to form new substances with the same elements. So ultimately, as a short, we may say chemical process or chemical reaction is the process in which 1, 2 or more than 2 reactants combine with each other so as to form new products with different chemical properties, and energy may be produced or may be required to be given to form new substances or to take place chemical reaction. Now, types of the chemical reactions with reference to heat. There may be 2 types of the chemical reaction: exothermic reaction, endothermic reaction. In case of the exo, बाहर निकालो, exit, अगर हम थिएटर में जाते हैं तो लिखा रहता है exit, वही दिखता है, बाकी तो सब अंधेरा होता है, कहाँ जाए वही दिखता रहता है exit exit. अगर कोई ऐसा पिक्चर आ गया तो पता चलता है कि चलो भैया एग्जिट द्वार कहाँ है, एग्जिट वे कहाँ है, राइट. सो एग्जिट, इसमें से हीट निकलेगी. सो दे आर नोन एज एक्सोथर्मिक रिएक्शन. एंड एंडो, अंदर आ जाओ भाई. इन एंडोथर्मिक रिएक्शन हीट विल बी एब्सॉर्ब, मींस कूलिंग इफेक्ट विल बी देयर. फॉर एग्जांपल प्लांट्स, फॉर एग्जांपल वो एक्चुअली एंडोथर्मिक रिएक्शन करते हैं और हमें कूलिंग प्रोड्यूस करते हैं, कूलिंग देते हैं. सो एनर्जी इज absorbed in case of the endothermic chemical reaction and energy is released in case of the exothermic reactions. Now, types of the chemical reactions. Actually, there are 5 different types of the chemical reactions: combination reaction, decomposition reaction, displacement chemical reaction, and double displacement reaction, and oxidation and reduction. Combinedly, they may be known as redox, means oxidation plus reduction means redox reaction. Now let us take the case of combination reaction. As the name itself indicates, a single product is formed from 2 or more than 2 reactants. Heat may be produced or may be absorbed. So let us take the example. For example, carbon when reacts with the oxygen, it produces carbon dioxide, and hydrogen reacts with the oxygen, produce H2O, means 2 elements are there, carbon and oxygen, and they produce one element, that is one compound, that is carbon dioxide. The combination of different types of the elements takes place. So this is known as combination reaction. Next is the decomposition reaction. Decompose कर देना, छुट्टा कर देना, तोड़ देना, मोड़ देना, वगैरह वगैरह. So chemical reaction in which larger molecule breaks down, तोड़ देना, फोड़ देना into smaller simple compounds. So decomposition requires energy for फोड़िंग, क्योंकि यहाँ पर हमको बाहर से एनर्जी देंगे तभी तो वो टूटेगा, right? Whereas the case was different in case of the combination reaction. Reaction in which energy is absorbed are known as endothermic, and reaction in which energy is liberated is known as exothermic reaction. These two types of the reactions you will have to remember. Anyway, let us come back to the main point, decomposition reaction. In case of the decomposition reaction means a chemical reaction in which larger molecules are broken down into smaller, simpler molecules. They are known as the decomposition reaction. Decomposition requires energy either in the form of heat, light, or electricity for breaking down the reactants. So mostly we may say decomposition reactions are exothermic reactions. They actually require, endothermic reactions. They actually require the energy. They absorb the energy from the environment. If they absorb, they will cool. Hence, mostly decomposition reactions are endothermic reactions because they absorb. Now the example, calcium carbonate. Calcium carbonate consumes the heat and produces calcium oxide and carbon dioxide. Next, we have already said that this reaction is used for the manufacturing of the cement. Displacement reaction, a chemical reaction in which part of the molecule is displaced by another atom or molecule is known as displacement reaction. A more reactive metal means अगर कोई तगड़ा इंसान है तो वो पतले इंसान को अपनी और जगह से हटा देगा. फॉर एग्जाम्पल किसी वृक्ष के नीचे, किसी मानो कि पेड़ के नीचे हम बैठे हैं और कोई वहां पर एक ही इंसान के बैठने की जगह कोई मोटा आ जाए कि नहीं मुझे तो यहां पर बैठना है, तू पतले हट जा. So this is the displacement reaction in which a more active metal will displace the less reactive metal from its salt. Example, ferrous sulfate and copper sulfate. Since ferrous is a fat, means वो तगड़ा है, मजबूत है, more reactive है than copper, so it displaces the copper and produces its own salt, that is ferrous sulfate, and leaves the copper aside. So copper sulfate solution which is blue in the nature, then it converts greenish due to the presence of the iron in the solution. Another few example, zinc and plumbum. We have already discussed that zinc and plumbum also displaces copper from the copper sulfate or copper chloride respectively solutions, and they produce zinc sulfate or plumbum chloride. So now let us define double displacement reaction. A chemical reaction in which there is an exchange of the ions between the reactants is called double displacement reaction. In case of the single displacement reaction or merely displacement reaction, one item will be replaced by more reactive item, whereas in case of the double displacement reaction, exchange of the ions will take place. A more reactive metal displaces a less active metal from its salt. For example, Na2SO4, that is sodium sulfate, when placed with barium chloride, the net products will be altogether different, that is sodium chloride, that is common salt, and barium sulfate. So this is double displacement reaction. Whereas what are the oxidation and reduction reaction? In oxidation reaction, substance gains or combines with the oxygen, means oxygen उस पे लग जाता है, that is oxidation reaction. A chemical reaction in which oxygen will get attached to the element, that is oxidation reaction. And the reaction in which oxygen is liberated, oxygen is dragged out, oxygen is removed from the item, from the compound, from the substance, from the molecule, that is known as reduction. Combination of these two are known as redox reactions, means reduction, red, oxidation, ox, redox reaction. For example, this is the example of redox reaction. For example, copper oxide when reacts with the hydrogen gas in the presence of heat, what do we observe? Oxygen from the copper gets detached, it is removed, so copper gets reduced, whereas it reacts with the hydrogen and hydrogen becomes water, H2O. Since hydrogen gets oxygen, so it is oxidized. So in this reaction we may say oxidation of the copper oxide has been done, and reduction of the copper oxide, since oxygen has been liberated from there, and oxidation has been taken place with the hydrogen. So this equation is known as redox reaction. Now, effects of oxidation in our day-to-day life. Mostly there are many effects, but mostly in your book which have been given emphasis are two effects which has been discussed in your book, that is corrosion and rancidity. So we'll restrict our discussion to these two effects only, that is corrosion and rancidity. So now what is corrosion, right? So corrosion is the process in which rusting will be there. Corrosion is a process in which item will be oxidized. Our body is also getting day by day oxidized. We are also getting oxidized. We are also getting rusted because we are taking oxygen, isn't it? So this converts metal into more stable states to form metal oxide, metal hydroxide, for example, ferrous oxide, ferrous hydroxide, etc. It gives more stable compounds, no doubt at all, naturally, but they are not useful to human life, right? They actually cost a lot because we will have to replace these worn out parts. So when a metal is attacked by substances around it, for example moisture, acid, etc., in the presence of oxygen, we said the material has been corroded, and this process is known as corrosion. Corrosion leads to damage to car bodies, bridges, iron railing, ships and whatnot, almost everywhere, right? So this is the example of corrosion. This ship might be very, very new one day, but now this has been rusted, this has been corroded, isn't it? So this is the effect of corrosion. Hence, it cost a lot to us. It cost a lot. We'll have to get rid of this corrosion by painting and whatnot. Now, what rancidity is? So rancidity is oxidation of our food item. When we place a food item open in the air, it gets dirty smell, taste and color start also getting changed, right? So this process is known as rancidity. So when any material, particularly food having fat or oil, is kept open in air, it gets oxidized and its smell, taste and color starts changing, right? Due to this, food is no more edible. How to prevent rancidity? By adding certain chemicals, for example antioxidants, which does not allow the oxygen to react with it, or keeping the food item in such containers which are airtight, which does not allow air to come inside. And last, the wafers of potatoes, which are generally supplied with the fluffy bags having nitrogen deep inside. Why? So that nitrogen does not allow the oxygen to come inside and does not allow the oxidation. Hence, these chips or vapors used to stay fresh for a longer time, and it does not get rancid. Okay, so this is the end of chapter number 1. I hope you might have liked, and for more such videos, stay tuned to our channel. In case of any doubt, you may write us by giving comment just below the video. Thank you.